Today, I'm going to show you why pi is actually equal to infinity, and if I don't, I will delete my YouTube channel. First, I am going to assume you know calculus, and if you don't know calculus, that's too bad, but I will try my best. Let's use the function 1 over x for this proof. If we graph this in the first quadrant, and only focused on the graph from the domain 1 to infinity, we should get this shape right here. Now, if we rotated this curve around the x-axis, we get a shape that kind of looks like a horn. This is called Gabriel's horn. Gabriel is an angel, and since the end is infinite, only an angel like him can grab the end. Anyways, I first want to find the volume of this horn. How does one with an Algebra 2 level brain do this? You can't. You need to know how to use integrals. The volume of a piece of this horn, known as a disk, is pi r squared times height. The radius is the length from the x-axis to 1 over x, so it is just 1 over x minus 0, which is just 1 over x. The height is delta x because the change in x gets smaller an infinite amount of times. Now, we will set up a definite integral from 1 to infinity of pi r squared times height. I'm going to pull out the constant pi and turn delta x into dx. 1 over x squared is 1 over x squared, or x to the negative 2. By changing this into a limit, whereas b increases without bound of pi times the definite integral from 1 to b of x to the negative 2 dx, we can solve this expression. Once we anti-differentiate, we get the limit as b increases without bound of pi times negative 1 over x from 1 to b. We can expand this by making negative 1 over x from 1 to b to negative 1 over b plus 1 over 1, which is just 1. Negative 1 over b will approach 0, so 0 plus 1 is just 1, times pi is just pi. So if we had a bucket of paint and poured it into the horn, exactly pi amount of paint will be used. This is weird, but isn't hard to comprehend because the horn will eventually become so small that no amount of paint will be able to fit inside. Now let's try to find the surface area of this horn. The formula for the surface area of revolution is this. Now it looks very complicated, so I will briefly explain it. The 2 pi comes from 2 pi r, which is circumference. Now you might be wondering, where did the radius go? It's actually just f of x, because like we talked about with volume, it's just the distance from 1 over x to 0. This last complicated square root is the slant height of the shape, or in a graphical sense, the arc length. The derivative of 1 over x is just negative 1 over x squared. If we substitute everything in, we get the limit as b increases without bound of 2 pi times the definite integral from 1 to b of 1 over x times the square root of 1 plus 1 over x to the 4th dx. Now this definite integral is hard and requires trig substitution to solve it, so I am going to solve an easier integral to solve this integral too. If I replace this square root with a 1, can we all agree that this 1 will always be smaller than this square root? The domain is 1 to infinity, so 1 plus 1 over x to the 4th will always start at 2, and the square root of 2 is slightly bigger than 1. So that means the original integral will always be bigger than this integral. Now this integral is much easier to solve. This is just an ln absolute value of x from 1 to b. If we expand it, we get the limit as b increases without bound of 2 pi times ln absolute value of b minus ln 1. ln 1 is 0, and the ln of infinity will be infinity, so this integral is infinity. Since the original integral is larger than the integral I just solved, it will also be infinity. That means that the surface area of Gabriel's horn is infinite. Wow! That means if we got that same bucket of paint and tried to paint the outer layer of the horn, we would not be able to. Now how does this prove that pi is equal to infinity? If we poked an infinite amount of tiny holes on the horn so the paint inside the horn could seep out onto the surface and cover it, we would theoretically cover the whole horn, but the surface area is infinite. So therefore, pi is equal to infinity.